Hello, Trig students. Sorry I couldn't be here today. I have this is the day I'm doing the field trip with my daughter. It was rescheduled to May 1st, so I'm getting a little 4-day weekend here. Or I guess 3-day, sorry. We are starting a new unit. We've got one more unit for this year. Wow, we are getting close to the end. We're going to take a look at kind of a cool mathematical I don't know, concept or idea. It's graphing, and I know how we all love graphing. And it's got a twist to it. It's not your usual x-y axis graphing. It's a new type of graph, a new way to graph. It's called polar coordinates. So what we're usually used to is graphing on what's called the Cartesian plane. And if you don't know, the story is that this guy named Descartes, all right, René Descartes, he's French, was lying in bed late one morning and saw a fly on the ceiling above him. Everybody look up. Everybody look up. You see a fly? As he watched the fly, he thought about how the fly's location could be described from the edges of the room as reference. The fly could be described as a certain left-right distance and a certain up-down distance. And as he was thinking about this, he developed essentially the XY coordinate system, which we now call the Cartesian plane after Descartes. Pretty cool, right? And it works really, really well. Except, all right, there are a couple of things. Well, one main thing that the Cartesian plane does not do well. It works well for functions, but it does not work well for non-functions. Non-functions. And so we are going to take a look at some graphs of non-functions. It's going to look pretty cool. I'll show you how to do it on the calculator tomorrow. Today we're just going to learn some very, very basics. I'm not here. So we get to redo the real cool stuff tomorrow and the next couple of days after that. All right? So this new way of graphing looks like this. It's not rectangular. It is circular. And so we divide the, plane, the space, into circles. And what that represents is the first number is not x, it's r. All right, the radius. The second number is the angle, theta. What angle are we looking at? And we use the radius and the angle to describe a point in space. So it's not xy, it's r theta. So let me show you how this works, and then I'll let you practice a little bit. All right, so first, the radius, my first point A, the radius is 3. So I come out here, 1, 2, 3. All right, so I went to the right 3, and then I'm going to arc around to pi over 4. So now using this radius, I'm going to come around to the angle pi over 4. That puts me right there. So that point is now A. So instead of describing the right and then the up, the rise and the run or something like that, we describe the radius and then the arc to get there. All right, let me do another one or two here so you can kind of get the feel for it. All right, letter B is a radius of 5, and then we're going to go all the way around the circle to 7 pi over 6. So I'm going to come out here, 1, 2, 3, 4, 5 is out here, and then I have to go around the circle to 7 pi over 6, all the way to here. So that point in space, that is B, a radius of 5, and an angle of 7 pi over 6. All right, and this next one, a negative. So yes, you are still allowed to have negatives in this. All right, you still can have negative numbers. So my radius is -2. So instead of going to the right, we go to the left, -2. And then pi over 4. So that one is not negative, so it is still counterclockwise. So I'm going to go this way, pi over 4. Now this is a little tricky. Not 2 pi over 4. I'm not coming around to this one. I'm just moving an angle of pi over 4. So I have to realize that puts me to here. All right, this angle is an angle of pi over 4. From pi to 5 pi over 4, that's an extra 1 pi over 4. So that is point C. All right, hopefully that lets you visualize a little bit of what we're doing, where these points are in space, and how to describe them. So we're going to practice that in a bit. I've got a OneNote worksheet for you to do where you get the circles and everything to help you graph. But with that, one special thing is that more than one set of coordinates can describe the same point. All right, you can have equivalent points, but using different coordinates, you'll land in the same place. So let's consider this point, 4, 5 pi over 4. All right, so where is that? I know I'm not doing Cartesian, but we still sometimes draw the x and y axis. All right, old habits die hard, am I right? Am I right? So that means I'm coming out here to 4. All right, there's my radius. And now my radius is going to spin around to 5 pi over 4. So 5 pi over 4 is right here. So that's my point. All right, that is, let me put it in black here, 4, 5 pi over 4. Now, what's the other way to get to that point? There's actually 3 others that will make you land in that exact same spot. All right, so the first one, I'm going to again start at the same place, a radius of 4. I'm going to start right here. But instead of going counterclockwise, I could go clockwise around this way and end up at the same place. Now to go to go clockwise, right? Yeah, to go clockwise, you just make the angle negative. Now how much of an angle do I need? So we just got to remember to divide the circle into pi over 4s. And I have to go 1, 2, 3 pi over 4s. There we go. That point lands you in the exact same spot. All right, the next strategy, I guess you could say, you might be able to guess is, well, we made the angle negative. What about the radius? If I start over here, let's see, do I have a good color? What about this one? If I start over here at negative 4, can I get to the same place? All right, so first if I go counterclockwise, well, I only have to go that far. And that's just 1 pi over 4. And then I can go clockwise. So again, I'm going to start over here at negative 4. Let's do this. This is a rainbow one, maybe. I'm going to still start right here at negative 4. But instead of going that short distance, I'm going to come all the way around. All the way around to there. It will still make me land at the same place. All right, how many pi over 4s is that? So 1, 2, 3, 4, 5, 6, 7. 7 pi over 4s. And because I'm going clockwise, it is negative 7 pi over 4. So there are 4 distinct points, I guess 4 distinct coordinates that can make you land on the same point. Now, technically, if you want to get fancy, there's an infinite number of points that can make you land there if you just keep spinning around the circle. So yes, you could add 2 pi to each of these or subtract. And if you add or subtract 2 pi, you would just spin around the circle one more time and land there. I think those are a bit trivial. The 4 distinct points I'd like you to find are these. All right, let me do one more, a little bit faster, so you can see how that works one more time. All right, so consider the point 8 comma 3 pi over 4. All right, so here, we're over here at 8 and 3 pi over 4. So 1, 2, 3 pi over 4 is over here. So there's my point right there. So the first way to get to that is 8 comma 3 pi over 4. Now, what are my other ways to get there? Well, I could go clockwise instead of counterclockwise. So that will be 8 comma negative 3 pi over 4. And then I could start on the negative side of my radius as well. Negative 8. Let's see, I can go this way, which would be, let me do positive first. I'm trying to stick to it here. Let me come around this way first, keeping it positive. How many pi over 4s is that? 1, 2, 3, 4, 5, 6, 7 pi over 4. And then my last one is negative 8, comma, and this time I'm going to go backwards this way, which would be negative pi over 4. That way. And there are my 4 distinct points. All right, those are the two, that's the main skill, I guess 2 skills, right? I got 2 skills for you that I want you to be able to do today. First is, can you graph where a point is? Second is, if I give you a point, can you write the other 3 coordinates that will make you land at the same place? So in Teams, there is a OneNote for you to click on. So I want you to click on that and try the few practice problems you've got, all right? Should be pretty simple. You should be able to draw in the OneNote, so make sure you click up here on a marker and you can actually draw on it. That was the easiest way I could think of to get you to do this. Good luck, and I'll see you tomorrow.